July 11, 1942, Dutch Harbor, Alaska. Lieutenant William Thies is flying patrol over the cold waters of the North Pacific when he spots something unusual on the small island of Akutan, a shape that doesn't belong, something man-made partially obscured by tall grass on a hillside near the beach. He circles lower for a better look and realizes with a shock that he's looking at an aircraft. And not just any aircraft, but a Japanese Zero fighter, sitting upright on the marshy ground with its landing gear extended as if the pilot had simply landed in the middle of nowhere and walked away. The Zero appears to be intact, not burned or obviously damaged, and Thies immediately radios his discovery to headquarters because American intelligence has been desperately trying to capture an intact Zero since the war began 8 months earlier. And here one sits, apparently abandoned and waiting to be recovered. For 8 months, American pilots in the Pacific have been fighting the Mitsubishi A6M Zero. And for 8 months, they have been dying in alarming numbers because the Zero is simply better than every American fighter in service. It's faster in a climb, turns tighter than anything the Americans can field, has longer range allowing it to escort bombers deep into enemy territory, and its maneuverability allows skilled Japanese pilots to dominate dogfights against American aircraft that can't match its performance. American fighter pilots have learned through bitter experience that trying to turn fight with a Zero is suicide, that the Zero can outmaneuver any American fighter at low speeds and moderate altitudes, and the Japanese pilots use this advantage ruthlessly to get onto the tail of American planes, where their 20mm cannons and 7.7mm machine guns can tear through American aircraft with devastating effectiveness. The psychological impact of the Zero's superiority on American pilots has been severe because for the first time in living memory, American aviators face an enemy with a qualitatively superior fighter. And this superiority has manifested in kill ratios that are deeply troubling to American commanders. In the early months of the Pacific War, Zeros routinely shoot down 3 or 4 or 5 American planes for every Zero lost. And American fighter pilots report feeling helpless against an opponent that can simply choose when and how to engage, while American planes struggle to keep up with the Zero's maneuvers. The mystique of Japanese technical inferiority that had characterized American assumptions before the war has been shattered by the Zero's performance, and American intelligence desperately wants to examine an intact Zero to understand its capabilities, discover its weaknesses, and develop tactics that will allow American pilots to fight back effectively. What Lieutenant Thies has found on Akutan Island is more valuable than he can possibly imagine, because this Zero represents the first opportunity for American engineers and test pilots to systematically examine and test a completely intact Japanese fighter under controlled conditions, and what they are about to discover will change American fighter tactics throughout the Pacific War. The Zero's legendary maneuverability comes at a price that Japanese designers deliberately accepted, but which American engineers will recognize as a fatal vulnerability. And once American pilots understand this weakness and learn how to exploit it, the Zero will transform from an invincible superfighter into a target that can be reliably defeated using tactics based on American aircraft strengths rather than trying to match the Zero's agility. This is the story of how one captured Zero changed the Pacific War by revealing that the most maneuverable fighter in the world was also, in critical ways, one of the most vulnerable. The story of how this particular Zero came to be sitting intact on Akutan Island, how American forces recovered it despite enormous difficulties, and how test pilots discovered the weakness that would ultimately doom thousands of Zeros begins with the Japanese raid on Dutch Harbor in June 1942, and reveals how one pilot's fatal mistake and his wingman's honorable decision created the intelligence breakthrough that shifted the balance of air power in the Pacific. Understanding what American engineers and pilots learned from testing the Akutan Zero requires understanding both what made the Zero so formidable in the first months of the war and what compromises Japanese designers made to achieve that performance, because the Zero's greatest strength and its fatal weakness were two sides of the same design philosophy that prioritized one aspect of fighter performance while accepting catastrophic vulnerabilities in others. When the Pacific War began with the attack on Pearl Harbor on December 7, 1941, American military and intelligence officials were shocked by the performance of Japanese aircraft, particularly the Zero fighter that had escorted the bombers to Pearl Harbor and which demonstrated capabilities that exceeded every pre-war estimate of Japanese aviation technology. American intelligence had consistently underestimated Japanese industrial and engineering capabilities based on racist assumptions about Asian technical inferiority and on reports from observers who had seen Japanese aircraft in China and mistakenly concluded that crude-looking designs and simple construction indicated poor performance. The reality was that Japanese aircraft designers had made deliberate choices to prioritize certain performance characteristics while accepting compromises in others, and the Zero represented the ultimate expression of this design philosophy with its extraordinary range, climb rate, and maneuverability achieved through radical weight reduction that eliminated armor protection, self-sealing fuel tanks, and structural strength beyond the minimum necessary to sustain flight loads. The Mitsubishi A6M0 had been designed in response to an Imperial Japanese Navy specification issued in 1937 that called for a carrier-based fighter with unprecedented performance. The Navy wanted an aircraft that could escort bombers on long-range missions exceeding 1,000 kilometers, that could climb faster than existing fighters, that could outmaneuver any opponent in a dogfight, and that could operate from aircraft carriers with their short flight decks and limited hangar space. These requirements were extraordinarily demanding and appeared almost contradictory because achieving long range required carrying more fuel, which added weight. Achieving high climb rates and maneuverability required minimizing weight, and operating from carriers required strong landing gear and robust structure to handle the stresses of carrier landings, which also added weight. Mitsubishi's chief designer Jiro Horikoshi understood that meeting all these requirements simultaneously would require radical compromises, and he made a decision that would define the Zero's character. He would minimize weight by any means necessary, even if this meant eliminating features that Western designers considered essential for pilot survival. Horikoshi's weight reduction campaign was ruthless and comprehensive. The Zero had no armor plate protecting the pilot. The fuel tanks were not self-sealing and would leak or catch fire when punctured. The structure used the thinnest aluminum that could sustain flight loads with minimal safety margins. Systems were simplified to eliminate unnecessary weight, and even the 20mm cannons that gave the Zero its firepower were chosen partly because they were lighter than heavier weapons. The result was a fighter that weighed only 1,180 kilograms empty compared to 2,110 kilograms for the American F-4F Wildcat that was its primary opponent in early Pacific battles, and this weight advantage translated into extraordinary performance. The Zero could climb to 6,000 meters in just 7 minutes compared to over 9 minutes for the Wildcat, could turn inside any American fighter with a turning radius so tight that American pilots reported Zeros seemed to pivot in place and had an operational range exceeding 3,000 kilometers with external drop tanks, which was more than double the range of American carrier fighters. In the early months of the Pacific War from December 1941 through mid-1942, this performance advantage allowed Japanese Zero pilots to dominate the air battles, shooting down American planes with what seemed like impunity while suffering relatively few losses themselves, over the Philippines, over Singapore, over the Dutch East Indies, and across the Pacific. The Zero established a reputation as an invincible fighter that American pilots learned to fear. And the psychological impact of facing a superior opponent manifested in declining morale, defensive tactics, and a sense among American air crews that Japanese air superiority was permanent and insurmountable. American commanders recognized that unless they could develop effective tactics against the Zero, American pilots would continue dying at unsustainable rates, and the only way to develop those tactics was to understand the Zero's capabilities and vulnerabilities through systematic testing of a captured aircraft. Several partial Zero wrecks had been recovered and examined by American intelligence in the first months of the war, and these examinations had revealed some useful information about the Zero's construction, engine specifications, and armament, but wrecked aircraft couldn't answer the critical questions about flight performance, handling characteristics, and operational capabilities that could only be determined through actual flight testing. American intelligence knew from combat reports and partial examinations that the Zero had no armor and no self-sealing fuel tanks, but they didn't know how this affected the aircraft's vulnerability to various types of ammunition, how it influenced the Zero's combat persistence, or how American pilots could exploit these weaknesses tactically. What American forces needed was an intact, flyable Zero that could be tested against American aircraft under controlled conditions where different tactics could be tried, performance envelopes could be mapped, and weaknesses could be systematically identified. The Zero that Lieutenant Thies spotted on Akutan Island represented exactly this opportunity, though the path to actually recovering and testing the aircraft would prove challenging. The Zero had arrived on Akutan through a series of events that began with the Japanese raid on Dutch Harbor on June 4, 1942, which was intended as a diversionary attack to draw American naval forces away from Midway Island, where the main Japanese offensive was planned. Petty Officer Tadayoshi Koga was flying as part of the Dutch Harbor attack force when his Zero was hit by ground fire, and the hit ruptured his oil return line, causing oil pressure to drop and the engine to begin overheating rapidly. Koga knew he couldn't make it back to his carrier and had to land immediately, and he spotted Akutan Island with what appeared to be a suitable landing area in a grassy field near the beach. What Koga couldn't see from altitude was that the apparent grass field was actually a marshy bog with thick vegetation hiding soft, wet ground underneath, and when his Zero touched down with landing gear extended, the wheels immediately sank into the soft earth, and the aircraft pitched forward violently, breaking Koga's neck instantly and leaving the Zero standing on its nose with the tail in the air. Koga's wingman circled overhead and saw the crash, saw that the Zero was stuck nose down, and assumed that Koga was dead or seriously injured. But Japanese protocol required that crashed aircraft be destroyed to prevent capture. And the wingman faced a terrible decision. He could strafe his friend's aircraft to set it on fire and prevent it from falling into American hands. But this would certainly kill Koga if he was still alive, or he could leave the aircraft intact, hoping that Koga might survive and be rescued, but risk the aircraft being captured by American forces. The wingman chose honor over protocol, refusing to fire on his comrade's aircraft, and he returned to his carrier to report the crash, and Japanese commanders, preoccupied with the Midway operation that was unfolding simultaneously, did not immediately organize a mission to destroy the crashed Zero on Akutan. By the time Japanese forces might have returned to destroy the aircraft, the Battle of Midway had ended in catastrophic Japanese defeat with 4 carriers lost, and Japanese forces were retreating westward, leaving the Zero on Akutan abandoned and undiscovered, except by Alaskan wildlife that eventually would begin nesting in the cockpit as weeks passed. When Lieutenant Thies reported his discovery on July 11th, American forces immediately recognized the intelligence value of the intact Zero and organized a recovery operation. But recovering an aircraft from a marshy island in Alaska presented substantial logistical challenges. The Zero couldn't simply be flown out because it was nose down with the propeller buried in the bog and the engine damaged from the crash and from weeks of exposure to Alaskan weather, and the island had no suitable runway for bringing in transport aircraft to carry the Zero away. The recovery team, led by aviation mechanics and engineers, reached Akutan by ship and faced the delicate task of extracting the Zero from the bog without causing further damage, and they spent days carefully digging around the aircraft, using jacks and wooden supports to gradually right the Zero from its nose-down position and improvising repairs to make the aircraft transportable. Once the Zero was extracted from the bog and secured, it was disassembled into major components that could be loaded onto a ship, transported to Dutch Harbor, and then shipped to the United States for reassembly and testing. The entire recovery operation took weeks and required substantial effort and resources, but American commanders considered it absolutely essential because the intelligence value of a flyable Zero far exceeded the costs of recovery. By September 1942, the Akutan Zero had been transported to Naval Air Station North Island in San Diego, California, where it was reassembled, repaired, and prepared for the comprehensive testing program that would finally reveal the Zero's secrets to American engineers and pilots. The testing program that American forces conducted on the Akutan Zero was systematic, thorough, and specifically designed to answer the tactical questions that mattered most to American fighter pilots who were fighting Zeros daily across the Pacific. The testing was conducted by experienced Navy and Marine Corps pilots who had combat experience against Zeros and understood what information would be most valuable. And these pilots were supported by engineers who took detailed measurements and recorded performance data that could be analyzed to understand exactly what the Zero could and couldn't do. The testing included speed runs at various altitudes to map the Zero's maximum speed envelope, climb tests to measure rate of climb at different altitudes and airspeeds, turning performance tests to determine minimum turning radius and maximum sustained turn rates, dive tests to see how the Zero handled at high speeds, and comparative tests against American fighters including the F-4F Wildcat, F-6F Hellcat, P-38 Lightning, and P-40 Warhawk to directly measure performance differences. The initial impression that American test pilots had when flying the Akutan Zero confirmed what combat pilots had been reporting. The Zero was extraordinarily maneuverable at low to moderate speeds with light, responsive controls that required minimal force to initiate turns, rolls, and other maneuvers, and the aircraft felt almost alive in the pilot's hands with an immediate response to control inputs. At speeds below 300 miles per hour, the Zero could turn inside any American fighter tested against it, and the difference was dramatic enough that American test pilots reported feeling helpless in turning engagements at these speeds because the Zero could complete nearly 2 full turns, while American fighters were completing 1 turn, allowing the Zero to position itself on the American aircraft's tail where its guns could be brought to bear. The Zero's climb performance was similarly impressive, with the ability to climb at steep angles while maintaining good control authority, and test pilots found that in a climbing engagement, the Zero could easily outclimb American fighters and gain altitude advantage that could then be converted into attack position. The Zero's range was confirmed to exceed American fighters by substantial margins, with the ability to operate more than 1,500 miles from base with drop tanks, which explained how Zeros could escort Japanese bombers on deep penetration missions while American fighters had to turn back when their fuel ran low. These test results confirmed that in certain regimes of flight, specifically low-speed turning fights and sustained climbs, the Zero was indeed superior to American aircraft and would win engagements conducted in these regimes. But as American test pilots pushed the Akutan Zero to higher speeds and more violent maneuvers, they began to discover the compromises that Japanese designers had made to achieve the Zero's low-speed agility, and these discoveries would prove to be the key to developing tactics that could defeat Zeros reliably. When American pilots pushed the Zero into high-speed dives, a common combat maneuver where a fighter would dive from altitude to attack an enemy below, they discovered that the Zero's controls became increasingly heavy and unresponsive as speed increased, and at speeds above 300 miles per hour, the control forces required to roll the aircraft or pull it into a turn became so heavy that pilots had to use both hands on the stick and pull with their full body weight, and even then, the Zero's response was sluggish and slow. At speeds approaching 400 miles per hour in a dive, the Zero's ailerons, the control surfaces that controlled roll, became almost immovable, requiring such enormous force that pilots literally couldn't move them enough to initiate a significant roll. And this meant that at high speeds, the Zero couldn't maneuver quickly enough to track a fast-moving target or to evade an attacker. American test pilots discovered that if they dove their aircraft to high speed and then attempted evasive maneuvers, the Zero simply couldn't follow because its controls were too heavy to respond quickly, and a Zero pilot attempting to pursue would either have to slow down to regain control authority, which would allow the American plane to escape, or continue at high speed without being able to aim effectively, which would result in missing the target. This discovery was revolutionary because it revealed that the Zero's legendary maneuverability only existed in a specific regime of flight, at low to moderate speeds below 300 miles per hour, and that outside this regime, the Zero was actually less maneuverable than American fighters that had been designed with different priorities. American fighters like the F-6F Hellcat, F-4U Corsair, and P-38 Lightning had heavier control forces at low speeds than the Zero, making them less agile in slow-turning fights. But their controls remained effective at high speeds where the Zero's controls became unacceptably heavy, and this meant that American aircraft could maneuver at speeds where the Zero couldn't follow. The dive testing revealed another critical weakness that stemmed from the Zero's lightweight construction. The aircraft had been designed with minimal structural margins, and the thin aluminum skin and lightweight frame meant that the Zero couldn't sustain the same G-forces in violent maneuvers that heavier American fighters could handle. When American pilots pulled hard on the controls to make tight, high-speed turns, they could feel the airframe flexing and groaning under the loads, and engineers who examined the Zero after high-speed test flights found that the thin skin was showing signs of stress with wrinkles and deformation appearing in areas of high loading. Japanese pilots were trained to avoid violent high-speed maneuvers that could overstress the airframe, but American pilots, accustomed to more robust aircraft, could maneuver more aggressively without fear of structural failure. The most dramatic discovery came during gunnery tests, where American pilots fired various weapons at the Zero's fuel tanks and structure to determine how vulnerable the unarmored, unprotected aircraft was to different types of damage. The tests confirmed that the Zero's fuel tanks, lacking self-sealing liners, would leak gasoline profusely when punctured, and tracer ammunition or incendiary rounds would often ignite the leaking fuel, causing fires that spread rapidly through the aircraft's interior, where there was no fire suppression system, and where the lightweight aluminum structure provided minimal resistance to fire propagation. Multiple test pilots reported that hits to the fuel tanks with incendiary ammunition resulted in fires that engulfed the entire aircraft within seconds, and this explained the combat reports from American pilots who described Zeros literally exploding into fireballs when hit in the right place. The lack of armor protection meant that the Zero's pilot was extraordinarily vulnerable to gunfire, and gunnery tests showed that even .50 caliber machine gun fire, standard armament on American fighters, would easily penetrate the Zero's thin skin and hit the pilot, engine, or fuel systems, and that the Zero had no redundancy or protection that might allow it to absorb damage and continue fighting. American fighters had armor plate behind the pilot's seat, armored glass in the windscreen, self-sealing fuel tanks that would automatically seal bullet holes, and robust construction that could often sustain substantial battle damage and still return to base. But the Zero had none of these features, meaning that any solid hit was likely to be catastrophic. American test pilots and tacticians synthesized these discoveries into a comprehensive understanding of the Zero's strengths and weaknesses that could be translated into tactical doctrine for combat pilots. And the fundamental insight was that American pilots should never fight the Zero in the regime where it was superior. Slow speed turning engagements below 300 miles per hour, but should instead force the fight into regimes where American aircraft had advantages, high-speed attacks, boom and zoom tactics, and situations that exploited the Zero's inability to maneuver at high speed. The tactical recommendations that emerged from testing the Akutan Zero would be disseminated to American fighter squadrons throughout the Pacific, and would fundamentally change how American pilots engaged Zeros. The thatch-weave defensive tactic that had been developed earlier based on combat experience was validated and refined based on the Akutan Zero tests, and this tactic involved 2 American fighters flying in a coordinated weaving pattern where each plane protected its partner's tail. And when a Zero attacked one plane, the other would turn into the attacker, forcing the Zero to either break off or face fire from the defending aircraft. The tests showed why this tactic worked. The Zero couldn't maintain high-speed maneuvers needed to quickly reposition between targets, so the weaving pattern forced Zeros into situations where they were always vulnerable to fire from one of the American planes. The boom and zoom tactic was refined based on understanding the Zero's high-speed control limitations, and American pilots were trained to use their aircraft's superior diving speed to attack from above at high speed, make a single firing pass while diving through the Zero's altitude, and then use their momentum to climb back to altitude before the Zero could respond. The key was to never slow down and enter a turning fight where the Zero's advantages could be exploited, and the Akutan Zero tests proved that this tactic worked because at the high speeds of a diving attack, the Zero simply couldn't turn quickly enough to track the attacking aircraft, and by the time the Zero pilot could slow down to regain maneuverability, the American plane would already be climbing away out of range. American pilots were specifically instructed never to try to outturn a Zero at low speeds, never to engage in a slow-speed dogfight where Japanese pilots could use their aircraft's superior agility, and never to climb at low speed where the Zero could easily follow and gain position. Instead, they were taught to maintain high speed, to use diving attacks that exploited American aircraft's better high-speed handling, to work in pairs or groups where mutual support prevented Zeros from isolating individual targets, and to aim for the Zero's fuel tanks where even a few hits with incendiary ammunition could cause catastrophic fires. The new tactics based on insights from the Akutan Zero were disseminated to American fighter squadrons in the Pacific through intelligence reports, tactical bulletins, and training programs where experienced pilots who had fought Zeros shared the lessons with newly arrived squadrons. The impact on combat effectiveness was dramatic and immediate because American pilots who had previously felt helpless against Zeros now had specific tactics that worked reliably, and combat loss ratios began to shift in America's favor as pilots learned to fight smart rather than trying to match the Zero's agility. By late 1942 and into 1943, American pilots were consistently defeating Zeros using tactics based on exploiting the weaknesses revealed by testing the Akutan Zero, and the Zero's mystique of invincibility was shattered. The introduction of new American fighters designed with lessons learned from the Zero also shifted the balance because aircraft like the F-6F Hellcat and F-4U Corsair were specifically designed to excel in the high-speed, high-energy fighting that exploited Zero weaknesses. The Hellcat in particular was optimized for the boom and zoom tactics that worked against Zeros, with excellent high-speed handling, powerful armament that could quickly destroy the fragile Zero, armor and self-sealing tanks that allowed Hellcat pilots to absorb damage that would destroy a Zero, and sufficient performance to execute the high-speed attacks that Japanese pilots couldn't counter. The Corsair's exceptional speed and climb rate made it ideal for attacking from altitude and escaping before Zeros could respond, and both aircraft tilted the tactical balance decisively in favor of American pilots who now had both better tactics and better aircraft. By 1943, the Zero had transformed from the feared invincible superfighter of early 1942 into a target that well-trained American pilots could defeat reliably, and Japanese loss rates began climbing while American casualties declined. The fundamental dynamic had shifted because American pilots understood the Zero's limitations and had learned to fight in ways that exploited those limitations while avoiding situations where the Zero's strengths could be brought to bear. And Japanese pilots, trained in the pre-war doctrine of dogfighting and turning engagements, found themselves unable to force American pilots into the slow-speed turning fights where Zeros excelled. The Akutan Zero continued to be used for testing throughout the war as American forces evaluated new aircraft and tactics against a representative Japanese fighter, and the aircraft became a training tool where American pilots could fly against an actual Zero to understand its capabilities and practice the tactics that exploited its weaknesses. The Zero eventually was damaged in a training accident in 1945 and was retired from active use, but its contribution to American victory in the Pacific Air War was immeasurable because the insights gained from testing this single captured aircraft had changed how tens of thousands of American pilots fought against thousands of Japanese Zeros. The story of the Akutan Zero is ultimately a story about how technical intelligence and systematic testing can change the course of warfare, about how understanding an enemy's strengths and weaknesses is as important as having superior weapons, and about how tactical innovation based on exploiting enemy vulnerabilities can overcome initial disadvantages in equipment. The Zero was a formidable aircraft that represented Japanese designers' brilliant solution to the problems of carrier-based fighter design, given the constraints they faced. But the design philosophy that created the Zero's strengths also created fatal weaknesses that could be exploited once they were understood. Japanese designers had accepted the vulnerability created by eliminating armor and self-sealing tanks, because they believed that a more maneuverable aircraft would avoid being hit. And in the trained hands of pre-war Japanese naval pilots, who were among the best in the world, this philosophy initially proved effective. But as the war progressed and veteran Japanese pilots were killed and replaced with less skilled pilots who received abbreviated training, the Zero's vulnerabilities became more apparent and more costly, and the aircraft that had terrorized American pilots in early 1942 became a flaming coffin that burned when hit because it lacked basic protection that might have allowed pilots to survive damage. American forces had the industrial capacity and engineering expertise to develop tactics, train pilots, and build new aircraft that could exploit Zero weaknesses faster than Japanese forces could adapt. And the combination of better tactics, better training, and eventually better aircraft turned the tables completely. By 1944, American pilots were achieving kill ratios of 10-to-1 against Zeros, and Japanese air power was being systematically destroyed by American fighters that no longer feared the Zero, but rather hunted it with confidence based on understanding exactly how to defeat it. The Akutan Zero taught American forces that the key to defeating a technically superior opponent isn't necessarily building a better weapon, but rather understanding the opponent's strengths and weaknesses well enough to develop tactics that exploit vulnerabilities while avoiding situations where the opponent's strengths can be decisive. This lesson applied not just to fighter combat, but to all aspects of warfare, and the systematic approach to technical intelligence that characterized the Akutan Zero project became a model for how American forces approached the problem of understanding and defeating enemy systems throughout the war and beyond. The captured Zero that Petty Officer Koga crashed on Akutan Island in June 1942 became one of the most consequential pieces of captured military equipment in history, because the intelligence gained from testing that single aircraft influenced thousands of air combat engagements throughout the Pacific War, and saved countless American lives by giving pilots the knowledge and tactics they needed to defeat an enemy that had initially seemed invincible. The Zero remained a capable aircraft in the hands of skilled pilots throughout the war, but it never again achieved the dominance it had enjoyed in the first months of the Pacific War because American pilots knew its secrets and had learned to fight in ways that turned the Zero's greatest strength, its extraordinary low-speed maneuverability, into an irrelevant capability that couldn't be brought to bear against high-speed attacks that exploited its catastrophic weaknesses.